Okay, so this is the video for problem 5, exam 2. Well, the problem states that the following code is designed to add two square matrices with dimension 509, 509. Modify the program to parallelize the computation, use as many as 8 cores, and propose the best data decomposition method. Notice 509 is not exactly divisible by 8. Well, yeah, this is a problem because we must use all the cells or all the lines within the matrix, right? Well, we made up first example to better understand what we did. Well, first we created the threads. Here we have the uh, number of threads array and the handle array. Well, we create the threads here in this line, and we send the number of thread that is going to be created, and with that we are going to be able to know how many lines is each thread going to be executing or calculating. Well, here we have the thread routine, and what we basically did was to add the last the well the residual of the division of the dimension between the number of threads. So the residual will be added to the last thread. Well, in this part we checked if the thread is the last or not. If it is not the last, then the end chunk should be a normal chunk. This is without adding the residual. Here we can see that, well, the last line to be calculated for the non-ending threads, not the last thread, will be the dimension of the interval multiplied by the number of thread plus 1. And, well, the value of the end line, or the end line of the last thread will be the dimension of the interval multiplied by the number of thread plus 1 plus the residual. This is the dimension of threads, percentage of the number of threads. Well, here we made up a little example with a little matrix of only 7 by 7 dimension, and the number of threads will be 4. Here we can check if we execute the program. Well, that the final value is 98. And, well, here we have some examples of the summation. This is, well, the matrix is filled with only ones, so each cell should have values of 2. In this case, we see that it has values of 2. We checked the initial value of the matrix, the last value of the matrix, and, well, some intermediate value, right? Well, here we have an example of what we are doing with this little matrix. This is a matrix of 7 by 7 filled with ones. Well, in this case we have thread number 0, thread number 0 here too. So thread number 0 will be summing the first lines. Then we have thread number 2, thread 1, thread number 1, then thread number 2, and thread number 3, as we have 4 cores, is the last one. And thread number 3 will be in charge of one line plus the residual. This is if we divide 7/4, we have 1.75, but as we are using ints, we will only get 1, right? So the residual will be 3 lines per matrix. So that's why we add 3 more lines to thread number 3. And here we have the example of summations. We see that we are summing up the matrices, the first and the second matrix, and we have all filled with 2s. And if we check the final value of the summation of all the cells, well, we have a final value of 98. And well, if we do the first example that is proposed in the exam, dimension 509 and number of threads should be 8. We can check this, we can run. Oh, okay, yeah. Maybe I should comment this one. And we have the same number, 222, but we have a different final summation or accumulation. This is well, a very large number, and if we check that number if we are actually doing the summation right, and well, we obtain that 509 multiplied by 509, that is the number of cells filled with 1s and of the first matrix. Well, we see we obtain this large number. Well, we have it twice, and if we sum up those numbers, well, we obtain this very large number. It's like 500,000 and something, and we obtain the same number here, right? So well, that was our implementation. In this case, if we divide 509 over 8, well, we get 63, and well, that 63, if we assign it to 8 threads, you obtain 504. So we are missing 5 lines, right? So those 5 lines are assigned. 5 lines are assigned to thread 7, which is the last thread. Well, that was our implementation, and it works well. And well, that's it.